Hello, good afternoon. Good afternoon, Unu.
Hello, good afternoon, Joan.
So thank you all for joining us today. So we're just about to start our today's session. For those who are just watching us for the first time, we call these sessions or these webinars the weatherproofing meetings. So this is a concept that we brought up pretty much a year ago. So it's been a year that we're doing this sort of session. So every 2 weeks, so twice a month, with different topics, different thematics. And we thought that it is always good to bring it back for what we really know for. In this case, we're talking about our facade waterproofing fire rated systems. Um, you have here available a chat or a Q&A. So during the presentation, feel also free to place any inquiries. We'll be glad to answer in the meantime or by the end of the presentation. We'll also leave there our contacts if something more specific. We'll also be glad to help you. So when it comes to facades, today we're focusing more on the rain screen cladding scheme. So this is a pretty well-known scheme throughout the UK and around the world. So is and in terms of fire episodes, we understand that these keep on happening. So obviously Grenfell being the biggest one in the past few years, but this keep on happening. So we have there 2019s, even the past year. This is more in the Middle East as well, Madrid, South Korea. So fires keep on happening. The question here is what we can do to obviously improve. And the main reason we brought up this sort of to the discussion to the table is always try to improve our products, always trying to, in terms of liability, have the best in terms of fire reaction materials. And the whole question is to future-proof our buildings. We understand new amendments, new codes, even document B, building regulations. This is keep on changing. So we understand that minimum classification still building above 18 meters is class B for some, but there's a lot of exclusions. In our view, we need to look toward to a minimum as A2, S1, D0, or A1 if possible. This is not only in UK. If you go, we're very strong as well on the Middle East market. So if you go to the Dubai Civil Code, there are very strict measurements there as well in terms of fire reaction or when picking materials for a building, and they're looking for A2 as a minimum. So if we really look here to trying to understand how we actually these materials are tested or understand the tested standards. So basic standard for material fire reactions is the 13501. Okay, so we have here three categories when analyzing a reaction to fire. So the if you pick the A here, it is a material, or A1 is a material that will not contribute to any stage of fire. So we'll say some say it's non-combustible. That really depends on the literature. But if you go to F, obviously we have a very combustible material. Same thing we need to look to is the smoke production. So that goes the S. S1 is no smoke or the lowest smoke production as possible. S3 is lots of smoke or limited smoke. Flaming droplets also a huge important factor because this will also allow the materials, to travel to the cavities. If one droplet goes to one floor to another side smoke, so we need to understand here that the flaming droplet particle. So again, it has this classification as a D. So if we go to a D0, is a material has no droplets at all, and D2, so unlimited and quite a lot of flaming droplets particles. We understand, and in terms of weatherproofing, we have here on the facade, so many different materials. So beside the cladding itself, we have, single lining membranes as a breather, as a vapor, and that's what we're going to discuss further here today. But we also have thermal insulation, part of the stone wall, in the inside, the VCL as well. So lots of factors, lots of materials to look to when picking. In our view, we are able to offer externally a breather membrane and internally a VCL as a A1. and we're going to discuss this further in the presentation. But the whole purpose here is try to future-proof or apply as much as possible better materials into a fire reaction, especially when you look into range pink lighting facades when we have full facade or full opaque areas. If we go deeply to the 13501, we understand that inside the standards, we have here two other standards that test the non-combustibility of a material. So the ISO 1182 and the 1716. If we do not pass sort of specific criteria under this standard, so you cannot go even further as a A1 or A2, the material needs to go pass it to another a specification standard. In this case is the SPI test, the single burning item, which is the 13823. The single burning test here is really important because this will sort of replicate as the materials will be applied in the facade, and that you understand when we go further in the presentation why we say a system, okay? Because this will include a lot of stuff besides the membrane, besides the one single material itself. So the 1182 is a combustibility test. So it goes here, if you look to this picture, so a specimen goes inside, and it's quite simple. So it needs the material itself, it's burned. It goes to over 750 Celsius degrees. And then it will measure after it if it was lost some weight or not. And that's where you understand is combustibility. The other is the calorimeter, okay, which is quite important. And again, if you go here under to the standard, it needs to pass sort of criteria, in this case, millijoules per kilogram. If it goes above 2 or beyond 2, it will not go further into the classification itself. And that's not only for even if you go look for a material as an insulation or a membrane, in our case, that had different layers. Each layer of the membrane, each part of the composition of the membrane are tested individually to understand how this will go further or not under the testing itself, specific on the calorimeter. The 13823, which is the reaction to fire, is exactly what I was talking. So this is a single burning test. Is a test that they use a corner, so around one by 50 centimeters, 1 meter by 50 centimeters, specifically 925, which they try to replicate exactly as a bit of wall, and has our application in this case, including our membranes, the VCL or the breather membranes, to try to understand how the material behaves. It's really important here that how the materials is fixed, if it has any sort of tapes, or the joints itself, because this is trying again to replicate the end use facade application. And doing all of this, we come up with a system. And now I'd like to invite Nuno to talk a little bit more further here as we go beyond in the presentation.
Yes, thank you, João. So like you said before, so we have here both solutions, a breather FR membrane and a vapor FR membrane, and a standard application here in this picture. And as you said, you usually apply the breather membrane on the external face of the wall, of the facade, and the vapor FR membrane on the internal part of the facade wall. And so, like you said, it's really important for us to test the membranes like we did, and we got A1 fire-rated membranes standalone. Though we need to pay attention to what CWCT says in its fire guidance that was issued in September 2020, last year, and we are very aligned with CWCT. And what they say is that we should always look for the scope of the field of application of your materials. So we always need to test our products simulating the end use application. And so we felt the need to additional to the test that we have made to the vapor membrane and the breather membrane, to actually test it as a system, simulating the end use on a project. And so if you can go through to the next slide, we will be able to see that. So Like I was saying, our membranes, when tested standalone, were A1 fire rated, so best possible rate. And when tested as a system, got A2 fire rated. And so, like you can see here in these pictures in pink, you can see that we have tested this system simulating the end use on a facade. And so we try to over exaggerate actually on the perforation, on the amount of tapes that we are going to apply, so that we are on the safe side here when we are actually at site. So we did we simulated all the application here. We did the overlaps. We exaggerated on the tapes. We did it with perforations on the walls, because this is really important. Perforations are weak spots on our facades, and we always try to work with those weak spots on a facade. We do design reviews with our clients to try and get the best possible solution to those weak spots on your facade. And so we did all that, like we can see here in these pictures, using our 2-adjoint DF tapes, our Effisus adhesive KF plus P, and like you can see here, we got approved and we got class A2 S1D0. So we are also on the safe side when applying this at site. João, if you don't mind to explain the fire testing here more in detail now.
Yeah, again, no, it's really important to mention, because the membrane itself is actually A1, so that's what we call it. The membrane is standalone. When tested standalone, or A1. So there's nothing better in the market for those two materials in terms of fire reaction. But again, we're looking here to try to replicate the software application. So that's why we got the A2, because the question remains, there's still some A2 membranes in the market. But when we say, how about your tape? How about your past adhesive? Was this included? Was this tested? So we're really confident on what we bring it to the market. So, and this is the past couple of years, because we always trying to improve and always try to push further in terms of the field of application of a product itself. In this particular case, either for the breather, membrane, or the VCL, we have pretty much 3 accessories. So one for the joints, one for perimeter seal. When you say perimeter seal, especially on top of bottom of the slab, window reviews, really important to have a material to attach or goes to this different substrate like concrete. So we have a specific tape that goes to concrete that allows some sort of movement or elongation itself for the membrane, as the membranes do not elongate. So we're really confident on that. This third pictures I would like to highlight here, the bonding KF plus P. It's our past adhesive. So especially when we go to this perforation, so inside here you have the VCL. We always going to have those electrical box sockets, pipes coming through the VCL, and this is always need to be amended, always to be fitted at site. And we need to have, with confidence, accessories that waterproof or seal, air tightness, huge important factor in this case, because for the VCL itself, it not only will prevent fire, but in terms of smoke and toxicity, because the membranes are airtight. So we're confident on the accessory applying, and again, always tested as a system. Same thing here in the VCL, the breather, you have these perforations outside, so the brackets itself that perforates the membrane. So we have specific tapes that goes through there as well. We have actually done additional testings. This is a standard that some of you might not know, but it's a pretty common standard, American standard. So the ASTM E84. So using in US, but as well on the Middle East market. It's a test that try to test the flame spread and the smoke development. So it's a 7.5 meter long standard tunnel, goes a sample 7.5 by half a meter wide inside the tunnel. Here you can see 0, 1, 2, 3, 4. It's exactly how the fire going to propagate inside. And the results are quite amazing what we have for both materials. So if you look here to the index itself, a material classified as class 1 or A, in terms of flame spread, it needs to go to 0 to 25, smoke development index to 4 to 450. And the results that we have here are amazing for the breather membrane. Obviously, they're both passed as a class 1 or class A. But specifically on the vapor FR, we got flame spread index 0, smoke development index 0. This gives us extra confidence. So besides these testings or the 13501, we have the ESTM 84. We have done obviously the British standard quite common, the 8414. So full scale mockup, and they all pass it. So we're really confident in the system that we're providing. No, just talking a little bit more about here about the breather membrane. What
Yes.
do you like to highlight here?
Yeah, well, in addition to the fire resistance, of course, the membranes need to have also different aspects that we should talk about here. And when we are talking about the breather membrane, of course, it needs to be watertight and vapor permeable. This is a membrane that is applied on the external face of the wall, and it needs to be vapor permeable in order to allow the wall to actually breathe. And if it doesn't happen, of course, you are allowing water to condensate inside your wall, and it can lead to mold growth and corrosion of facade elements. And so this needs to be a characteristic of your breather membrane, which is also happening here with our breather FR membrane. It aside from the fire resistant, like you said before, it needs to be UV resistant. Its mechanical resistance to tear and tensile was tested as well. This is a very flexible solution that we have. Of course, this solution complies to CE marking. And like I said, we have done further testing on the membrane. And when compared to a standard membrane, Class B, you can see clearly here that the tensile strength and the tear resistance is a lot better in our A1 fire-rated membrane than on standard membrane Class B. And this happens because of its composition. This is a membrane that has fiberglass fleece in its composition, and this allows for this solution to actually be a lot better in terms of mechanical resistance. So the same applies here for the vapor membrane as well. Our vapor membrane provides a vapor barrier on the internal face of the wall. It needs to be watertight and airtight. This is applied on the inside of the wall, and of course you don't want air leakage from the inside to the outside. So when we are, for example, you have a warmer temperature on the inside, you don't want to allow any vapor to actually go to the outside of your wall, leading to the problems that I said previously: mold growth, corrosion of your wall, wall composition. And so this solution needs to be watertight and airtight. In addition to the characteristics that I just talked about, I would like to highlight the BREEAM and the LEED and EMI code requirements that this solution complies with. And this is very important because of the environmental laws that we have nowadays in the construction business. And so I would say that this complies with all regulations on the market right now. This is also in comparison with the Class B membrane. We have actually have better tensile strength and water vapor resistance than a vapor membrane Class B, standard membrane Class B. And this is also happening because of its composition. So this is a membrane that has fiberglass fleece as well, but also it has aluminum foil in its composition that allows for a better results in terms of water vapor resistance. And that's what we want to achieve when applying these kind of products from the inside of your building. João, thank you. So here we have an example of an application on a project in London. So a breather application with all the perforations. Like I said before, we at Effisus, we really pay close attention to this kind of perforations and these kind of details. We always advise our clients to take a look at specifically these weak points, because when you are perforating your facade, you can allow water to come inside your wall. And imagine you have a problem on a 20-story building, and you have a problem on one of these stories, and it's a nightmare to actually go to that spot and actually fix whatever it's happening to your wall, that will lead to mold growth, that will lead to water coming inside of your apartment, for example. And this is what we advise always to our clients, to actually pay close attention to these kind of perforations. In the next slide, we can see an application of our vapor membrane, also a project in London. So yeah, I think this covers the applications here of our products. Here you can see, for example, on the bottom and on the top of the wall, that we have these spots really well sealed in order to not allow the vapor to go to the outside. And of course, we do study the different substrates that we have in our projects, because if you have a concrete substrate like you have here, or if you have differential movements on your building, we have to study that in detail in order to provide you the best adhesive tapes, the best accessories that you should apply at your projects in order to allow for these differential movements to be absorbed by the products. So we also did that in this specific project with our clients.
Yeah. I would like just to highlight here, no, no,
Yes.
how easy it is to apply the membrane, because this is a
Yes.
question that we constantly get asked, especially for first projects, because obviously the guys need to be extra careful on the installation when picking the such a materials after rainfall, and why we go further on fire reaction. But the application itself, it's quite standard. Guys are used to apply standard polyethylene, or just plastic VCLs. In our case, it will be pretty much the same. The only difference here is actually how we label the accessories. The installation is quite standard. So in this case, you have here the SFS, the studs. You can quite see on the right picture. So each studs, we apply one of our double-sided tapes, usually every half a meter, every 600 millimeters. So then you apply the membrane on top of that. You have overlaps, usually 150, 100 mils, so lapping the membrane. And the huge difference here is how we actually extend to the top and bottom of the slab in this case, and that's where we use our specific tape, which is the 2-1DS, and we've been talking. And this membrane goes straight to the concrete, so most of the times no primer need, and gives you a really nice seal around or all around the membrane itself. Really nice to see here on on the left, on the front block, you can not only see the vapor, but you can also see the breather membrane, which is the front block. This picture is from Kensington Road. Some of you might know this project, so Berkeley Homes project. And I think we reached to the end of the presentation. Again, those sessions are quite fast, so we try to stick to 25, 30 minutes. We just reached it on time. It's important to mention we have done a lot of technical articles you can find on a website. Besides that, we release since January this document that goes specific to the consultants, architects. It's sort of a guidance when picking the sort of a material, so which accessory, how it should be applied, and you can also find this on the website. Just to highlight, we got into the NBS source and Ribas as a CPD provider since February, I believe so. So all of information is ready for specification. Approved CPD contents are already available to be booked as well, besides those webinars. So once again, thank you so much for all of you for attending today. If you have any additional query, we'll be glad to help you further with this. We also have a dedicated design team, I believe Nelson mentioned, and we do the sort of reviews for our clients. This is free of charge service. So any additional query, anything you might be relatable, you can think we could help you, feel free to send us an email to me or to Nuno. We're more than glad to help you. Thank you so much.
Thank you all.